Okay, so I think we can probably get started now. So welcome, good morning, everybody. Thanks very much for your time today. My name's Paul Brett. I'm responsible for Cubro's business in the UK, Ireland, and Middle East, and I'll be your host today. I'm joined by Lucas Ettlinger, who's a solutions engineer based at our headquarters in Vienna. So over the next 45 minutes, we'll be talking about how to maximize network security by using network visibility technology. And the majority of the content will be covered by Lucas. And Lucas will also provide a demonstration of how we set up that solution. Before I hand over to Lucas, I'm just going to talk a little bit about the value of network visibility for network security to add some context around the solution, and then I'll come back at the end to summarize and cover the Q&A. Just a couple of housekeeping points before we get started. Actually, firstly, there are some handouts and some documents that you're free to download that might be interesting. We have a case study, an ebook, and various other interesting documents and resources available to you. We'll also be running a number of polls as well, and we'd really appreciate your feedback and response to those. That helps us just to continue to keep the webinar content relevant and interesting. And then finally, actually, if you have, obviously there's a Q&A session at the end, but if you have any questions as we go, please put those in the chat and we'll answer those as we go, if that's possible. That pretty much takes us, I guess that covers the agenda. So if we move now to just talk a bit about the value of network visibility. So I guess the first point I would make is that key point is that network visibility obviously isn't a network security technology, but what it does is facilitates and enhances network security to improve network security posture, improve the technical and the commercial effectiveness of network security technology, and also to improve business continuity and operational flexibility. I'll come back to those in a second, but just to add a little bit of context around that, if you look to the left side of the slide, the environment that we're typically working in today is a complex network environment of overlay architectures. They're typically multi-environments, so whether that's on-premise or cloud, or probably again typically a hybrid of the two. They typically include multimedia types and application types. They're normally high performance with high capacity, and they carry a lot of data. They also provide access to many systems, applications, and data. And I should add actually people as well, which is a very key point because people remain consistently the highest attack or successful attack vector into organizations today. There are many network security challenges, and these are some of the most prominent, I would say. The first of those being obviously the typical cost of a network breach. Now that number of 4.9 million is the average global breach produced by the latest IBM report. Now, while that's not necessarily relevant for all of us in the room, and that will vary according to organization type, size, and so on, the key point is that it's typically significant and it's growing. That was a 10% increase year on year. Networks represent a large attack surface, so many opportunities for attack, and that includes, of course, things like north-south traffic. So that's ingress and egress to and from networks, and east-west traffic for traffic that's contained within the network itself. And the last 2 points there are really, I guess, very much related. There's no silver bullet as far as a technical solution for network security is concerned, and an effective strategy typically involves a layered approach using multiple network security tools, which has, again, typically a significant cost. And those tools can include things like firewalls, network detection and response, maybe intrusion detection type technology, SIEM technology, where network is a component of the overall SIEM scope. And interestingly, again, network visibility provides network traffic data feeds to each of those different technologies. So that brings us to, so what does network visibility do, and what does that add to network security? Well, as I mentioned, network visibility is a facilitator and an enhancer of network security. You can think of it, I guess, conceptually as a vendor-independent appliance-based middleware type technology, which sits between the network and the network security tools. It connects to the network and observes all traffic crossing that network. It duplicates the network traffic that needs to be analyzed for security purposes, and typically from multiple sources. It then optimizes that duplicated traffic and generates consolidated, optimized data feeds, which it then passes to one or a number of network security tools. Optimization typically includes things like filtering out traffic that does not need to be analyzed, aggregating a high number of inputs to a much smaller number of outputs, or I should say, which combine as the or deliver the optimized data feeds to those network security tools, and then other capabilities, things like deduplication and so on, which Lucas will cover shortly. So because of those capabilities, what that means is that network visibility guarantees a copy of all of the relevant traffic that needs to be analyzed and removes network blind spots to in turn improve network security posture. Because we're able to filter out irrelevant traffic, that means that the network security tools don't have to waste time analyze traffic that has no value. So that helps to improve their effectiveness and their efficiency. It also means it reduces the loading on those network security tools, which reduces CapEx and OpEx, because typically network security tools are priced according to size, capacity, or loading in some respect. And then finally, network visibility has the ability, as I mentioned, to push the traffic out to one or a number of different tools, or that could be a number of different ports on the same tool, or it could be a number of different ports on different tools. We're able to load balance across those ports and those devices, which in combination with an inline bypass capability means that we can remove single points of failure within the network security architecture, which also, of course, feeds back into the network security posture as well. And then finally, because we're vendor independent, that means that the user of network visibility technology is able to use or able to deploy different technologies or the different optimal technologies when they're needed. Because we're vendor independent, we remove vendor locking, and so that allows them to deploy the most appropriate technical solution and commercial solution as their operation evolves over time and as the threat landscape evolves over time. So that's everything that I was going to cover, just to give some context and really just to highlight the value that network visibility solutions deliver to network security. I'll pass over to Lucas now, who will take you through the detail of what network visibility technology delivers to network security solutions, and I'll come back at the end for the summary and Q&A. Lucas.
Perfect. Also, hello and welcome from my side. So let me start sharing my screen, and then we can just jump right into it. I've prepared, as Paul already said, some slides, and also in addition, also a live demo later on. So I hope you see the screen. I'm not sure if it's working or not, but Paul will tell me, I guess.
Yeah, no slides up yet.
Okay. That's bad. Let's see if it works. It would allow me to share.
Should I share them, Lucas, from the platform?
Yeah, we can at least do that and then later on, but for the demo we need it. So.
Okay, good. Let's start.
Yeah, let's start with the slides and then we could.
All right.
Yeah, perfect. Then let's just start into it. There's a few topics that we will cover, or that I will cover now in my slides. Of course, network visibility is critical for security operations. Yeah, why is that? Then, of course, there's always The key, how to get to the traffic. So there's multiple things how to get to access to the traffic: tabs, spam ports, any other source. And then what is even the packet broker helping in all this scenario? Does it optimize the security tools? How can you use it? Then a few use cases. And then last but not least, then the demo where I will show just a quick configuration that you can see, that you get the feeling on how easy it would be to deploy the packet broker and how it could help in certain situations. First of all, and I think this is the most important sentence now of the whole webinar, is yeah, you can't analyze what you don't see. So if you don't have access to the traffic and you're not able to bring the traffic to the security tool, of course, the security tool will not be able to detect any threats or anything. So it will just be useless. So therefore, most important thing, get the traffic there. Secondly, of course, is that today there's challenges which might not have been there a few years ago. First of all, bandwidth growth. Also, you see that in enterprise networks, you see it in mobile operators, you see it everywhere in daily life. The bandwidth is just getting more and more and more, which means also that the security tools need to be expanded very regularly. Then also in addition is coming the more, or the big range of use cases that these days many customers have. So you don't only have like a performance monitoring tool, then in addition you have like a security tool. In addition, you have maybe some metadata tool for net flow and so on. And then in parallel of all of that, you maybe also um, have tools like a Wireshark, so like an instant capture, so something to really troubleshoot. And all these kind of things add complexity to all of the monitoring chain. So therefore, from our point of view, it makes sense to have some sort of middleware, which the packet broker can be, just to distribute the right traffic then to the right tools. So not everything to everything, because it's not needed, but really the traffic that needs to go to a certain tool is then sent by the packet broker and can be selected there. But first of all, how to get even access to the data. So typically there's two big main players in that. First of all, the spam ports, and secondly, the tab. So spam port is usually something that the network already has, because the network already has, for example, a switch. It has already a router, so it has already network components. And these active network components usually have like a feature which mirrors certain traffic out, and you can send these via tunnel, for example, GRE, to a certain endpoint. Could be your probe directly, then you don't need any tab. But the problem is, as I already said, maybe sometimes you would need more than one endpoint. You'll not only have one security tool, the security tool maybe even has multiple ports, but your spam port configuration only allows one output. Secondly, these resources, this hardware which is in the network, is designed to switch or to route the traffic in the network. The main purpose of it is forwarding the traffic. The main purpose is not copying the traffic and feed it somewhere. So that means, of course, it's possible, but in the other hand, it's also somehow binding resources on this device, and could, of course, affect the live traffic, which is one of the biggest goals in monitoring, to not affect the live traffic. The monitoring should always be passive so that it has not any influence to the live traffic. But also the spam port, as it is on an active component, for example, software update could destroy this configuration, could lead to blind spots in the network. So therefore, our suggestion is, of course, as we are also a tab vendor, is to use tabs, or test access points, so really designed hardware, typically passive, for example, optical splitter or electrical tab, to really copy the traffic one-to-one to an output. It's very easy to use. So you just install it once and that's it. But, and the biggest drawback, of course, it's additional cost. Of course, you need to buy additional hardware. That's the way it is. But on the long term, this investment usually pays off, because if it's once installed, nothing typically happens, because the tab is more or less bulletproof. As said, it's a passive operation. most likely if it's an optical tap, it not even consumes electrical power. So now as we discussed how the traffic can be extracted, then is the question, but now how can even the packet broker help? Because now, okay, I can copy all the traffic. So the packet broker usually can receive packets from different sources. So as we said, it could be a middleware. So it can receive the traffic from a tap, from a span, like a tunnel. So all the traffic can be in one place aggregated. And then we can deliver the information to multiple tools. For example, we can copy the traffic, copy only certain traffic, copy only an IP address, forward everything, forward only a subnet. So whatever is needed can be done with the packet broker. And then last but not least, also traffic can be, we call it now optimized. So for example, depending on the packet broker product, unwanted duplicates can be removed with a deduplication mechanism. So let us go through the different options. First of all, tunnel termination header stripping. So as said, it's not always needed to have a tab. It's just our recommendation. So if you don't have a tab, typically traffic is coming somehow via a mirror session to a packet broker. So that means what does the packet broker need to get this traffic? It needs to be able to assign an IP address to one of its, let's say, tool ports, so the ports where the traffic comes in. So not only the management address, because on the management address, a management port, you will not get the traffic in. You want the traffic in the tool board. So you need to be able to do this. And then secondly, depending of course on your use case, we can either strip this header off, so remove a GRE header, forward only the original packet information to a tool, but if needed, also we can leave the GRE header on and just pass on these packets to the monitoring via Shark monitoring tool, whatever it should be. So this would be option one where the packet broker could help. Of course, as you see, I mean, we can also receive traffic from multiple mirror sources. So it's not only one, it's multiple even per port. And if you see here, it's like a 48 port unit. So would more or less mean unlimited amount of mirror session inputs. Secondly, would be the replication. As already said, typically nowadays, you not only have like one particular monitoring tool, you not only have one output, you have multiple outputs of the packet broker in parallel. So that means also typically traffic needs to be replicated, needs to be copied. So I need multiple copies of the same packet to feed it to different outputs. Very typical scenario, typically also very easy to set up, but we will show later on. Of course, also, as said, selective replication. Maybe I don't need the full traffic copied. Maybe I need only one IP address, one subnet, a UDP port, whatsoever most likely that you can think of can just be copied and copied to a second output or a third output or whatever is needed. Then the deduplication. Deduplication typically is happening if you have a larger network and I tap, and in this addition also have spam port. So I have sources, different sources, but the packet is traveling through these different sources. That means I have like an east-west tap, but also on like the north-south, I also have a tap. So the traffic is going from left to right, but also then later on it goes outside my network. That means I will capture this packet multiple times. So then there's different approaches. Either I want to have a really complete 100% monitoring where I see also even all the duplicates. Typically, this is not so wanted. Then secondly, it could be, of course, that the security monitoring tool, whatever it is, does a deduplication. Most of them can do that. But of course, this will cost, first of all, hardware resources. Sometimes also some license fees are applied to that. So there's typically additional cost, let's say, however these costs are calculated. The packet broker has already these features in. And with Cubro, as you know, all the features are always activated. So that means if you have a packet broker that supports a deduplication, it makes sense to already use it, not to waste any of money on your investment because you already bought this feature set. On the data application itself, it's always important to remember that data application just packet per packet typically will not work. Typically, as said, if you have multiple points in the network where I capture a packet, the packet most likely looks 99% the same, but some of the fields will be maybe different. For example, the time to live field, maybe even the MAC addresses because it goes through a router, or any other a certain part of the packet could be different from packet to packet, but still the payload is the same. And exactly for that, you see here on the right side, the ignore options. That means our algorithm, I can select what field of the packet broker should not look at. So for example, if I would enable here the time to live, just tick it, then the packet broker would compare the whole packet except time to live field. Or I can, in addition, so it's always an AND connection, time to live and MAC address, don't care about that. Whole layer 2, that means MAC address and VLAN, and so on. So I can just, so I can increment always more and more fields. I can just start to ignore if I want to. And then we come to the filtering part, which is of course the standard feature, the feature of an packet broker is I can do filtering depending on the product. Layer 2 to layer 4 fields are possible. On bigger ones, or let's say units with a CPU based, also higher layers could be possible, like regular expression. Then also I have the data application, VLAN remove and push. So also these are features which typically standard packet broker will be delivering. Why is that important? As said, if I have just a very simple aggregator, which does only do aggregation, so many connections in, very few connections out, that's an approach. Yes, it is. But in that case, typically, I only have the option to send everything to everywhere. And what that means is typically one of my tools will be overloaded, or I have just sent information there that is not needed. So for example, I have an NDR solution and in parallel, some instant capture solution. I would send all the traffic always to the capture. I would need a very big capture appliance to capture all the traffic, which, as we all know, typically is not the case. Typically, capture appliance will be something very slim, as cost for capture typically very high. So therefore, the filtering feature itself makes a lot of sense in the packet broker to have, and makes also a lot of sense to make use out of it. So this brings us to the last slide here. This is a demo which I just prepared and which we can now go through. I will show how quick we can configure such scenario. So we have a scenario with 4 ports in from a tab, and 1 GRE handle will be the input. And on the output, I have like an NDR solution with 2 times 10G, for example, can be an extra hop or name it, any of the other brands that are out there. And secondly, I also have an on-demand capture. And the goal would be to configure like that we can receive the GRE handle. Optional, we can also remove the header. Then in addition, we want to take all the traffic, load balance it to the NDR solution. Optional, we can also do the data application. And then last but not least, we can copy just a specific IP address to the NDR, but also on the on-demand capture. Good, so then I will just start sharing my screen, and then let's see. Tamana, it doesn't let me share my screen.
No.
Maybe let me just rejoin real quick. Give me just a second.
Okay. Paul, do you want to go through some of the summary items until Lucas joins, and then we can come back to that again? We cannot hear you, Paul, right now.
So let me just unmute myself. Yeah, let me just here's Lucas now.
Perfect. I think now it works.
Yes, we can see.
Very nice. Good. So now you see here, this is an XA 48200. So it's a unit 48 ports 10G, 2 times 100G, has a CPU, so we can also use the higher layer features. We see here my 4 ports, which are coming from the top, one coming from the span with a GRE handle. I have here my instant capture, and 2 times to an NDR solution. So just before we start, I will not send any traffic through. I will just show how the configuration is done, just to keep it simple. So first of all, we said we want to receive the GRE handle. We said GRE handle should be received at port 11. That means port 11 would now be connected to the network, to a switch, and needs to assign an IP address, so the endpoint of the handle. This can be very easily done. So I just go here, I have here my ICMP response. I will just select the port that we have, X11, add an IP address. We can say 2.168.0 dot whatever 16. We have an own network maybe designed and subnet for that, which is like let's keep it simple. And then you can select the MAC address for this port, whatever you want. Okay, I will just put here quickly FF confirm, and that's it. And this is the whole configuration to receive traffic on the X11 port. So now with this, you will be able to ping this port from the outside if it's connected to the network, and also to receive the traffic. So if we now want also to do the GRE termination, or the removal actually of the header, we also can do that. But first of all, we need to forward the traffic from the X11 port to our output. So what we can do, just drag and drop on our input X11, output maybe our NDR solution. We can do 2 ports, can select here load balancing, should be dynamic load balancing, confirm, that means if one of the port goes down, the other one will just take over all the traffic. Then we can go here. We just say this is GRE traffic that we want to strip the tunnel, select GRE, confirm, confirm, and that's it. And this would be the whole configuration to forward all the traffic, which is GRE, then remove the GRE tunnel and forward everything to 47 and 48. In addition, I can now do here now my filtering or forward everything. So for example, if I only have one subnet to forward because the other subnets are maybe not interested, I'm not interested in, so then I can just do that. So very easy setup. So I could just confirm, and that's it. So in addition, now we also have here our ports which are coming from the top. So there's 2 options now. Either I create a new policy, drag and drop in my ports, or if I want, for example, all the same filtering rules should apply, then I could just also add the ports here and modify my existing configuration. This, of course, always depends very much on the use case, on the flavor, of course, of the customer, but also depending on what is best for the use case. Sometimes it makes more sense to separate everything. Sometimes it's easier to put everything together. So if I just really have a pure aggregation scenario, of course I will just put all of the ports in the same group. Just for us now here, we can just do 2 groups. That means 1, 2, 3, and 4. Of course, now I've used this one here, my fault. So X11 should be here, this here. Yeah, then 3 and 4. And our output, again, NDR system, again, load balance. So there's different kind of load balance features that whatever is needed. Confirm, again, whatever ruling, take 1000, confirm. So easy as that, a very simple scenario can be set it up. So now what we have said is we also could enable on this one or on this one, doesn't matter. For now, we can enable the DID application. So you will see how to enable DID application. First of all, I need to make sure that the traffic goes to the CPU. So therefore, I can just say here to CPU, then the traffic will go to the CPU. Why I don't do it always, depending on, of course, the network speed, on the bandwidth, sometimes the CPU cannot handle all of the traffic. I mean, a CPU is a CPU, so it's not has not endless resources, but has a lot. So depending on the product, more or less. So therefore, sometimes it's just not needed to send all the traffic to CPU. As said again, depends very much on the use case. So to the CPU, and in the CPU, I will just forward everything, doesn't matter in our scenario here. And then let the unit quickly save the configuration. And after that, I will show you how to enable the DID application. You will see it's super straightforward because I can just say, okay, on my port X1234, I click just on my ingress group, go here to my advanced features, and I see here DID application. I can now select what I said before, ignore TCP, ignore the time to leave field, maybe ignore also the MAC addresses, and the time window here selects how long the time is between the copies. So if there's a copy received inside this 100 milliseconds, it will be treated as a copy. So if it's the same packet, if it's outside this, then the unit will treat it as like it was a resend. So it's a real copy which should be there. That's also, of course, preventing that the unit is still somehow not introducing too much of a delay. So if I would be able to have here a bigger number, would mean the unit also would need to have a very big buffer to store all the data. So then I can just confirm it, and that's it. And with this, all the DID application is happening. So not more than this is actually needed. So you see the configuration itself on our units is pretty straightforward. There is nothing to be worried or afraid about to deploy a packet broker. Typically, everything can be set up pretty easy. So now as we have this configuration and our NDR solution has now might found some IP addresses in the network which look strange. So then the security team says, okay, we want to have this specific traffic to a special output. We want to analyze this, for example, in a Wireshark or whatever tool. So what can be done is just add egress port group, we add another output, then we add here our 37, which is here. Then also we add, of course, our other outputs because the traffic should still go to the same output. So then, sorry, this was of course not ideal. Sorry, because we of course need a super group. So 37 and 48. So what it does now is the unit will copy the traffic I later on will specify, will copy the traffic to this group and to this group. So it will copy to 37, but also will copy to the load balancing group 47 and 48. So that means here only one copy, and here traffic will still be load balanced as before. So it's like copying to two different groups. I could also select here multiple ports. And then what we do here, we add here another rule, have maybe 50, and say, okay, the IP address of the network 10.0.0 Whatever, no, take something else. 55 something, 24. And all the traffic from also the backwards direction, this traffic I want to have at my analyzer. And with this configuration, we can just click confirm again. This configuration will now make sure that the traffic of this specified IP destination is going to my instant capture, but also is going still to the NDR solution. And in addition, all the remaining traffic, which is now untouched, will also still go to the NDR solution. So like this, I can build up my filtering and can make use of the packet broker. So I know, of course, this is not always needed, but still, if you do not have a packet broker, if you just forward everything via mirror ports to your analyzing tool, then it's very hard to achieve this kind of scenarios. And from our experience, from what we have seen, this is like a very typical scenario. So typically customer or the traffic, the analyzers, the guys who operate in the network, they have a use case which is monitoring, but also they have a use case which is troubleshooting, which is instant capturing, things like that. So therefore the filtering, the packet broker itself comes into place, and therefore from our point of view, we highly recommend to use TAP and packet broker combination in every network to do the monitoring. Yeah, and with that, I'm actually finished with my demo. So I would now hand back to Paul. If you have any, just put them in the chat. We can just answer it right now, then later on in the Q&A. And yeah, back to Paul.
Great, thanks, Lucas. So I guess by way of summary then, as we mentioned earlier, network visibility is not a security technology, but it facilitates and enhances network security. And it's able to generate optimized data feeds from multiple sources that are delivered to network security tools to help improve network security posture and therefore reduce the risk of security breaches and the consequences of those. And more specifically, what the values that network visibility solutions deliver is to improve network security posture by removing blind spots. It's able to improve the effectiveness, the technical effectiveness and efficiency of network security tools by filtering out irrelevant traffic and reducing the loading on those tools, which also in turn helps to reduce the CapEx and OpEx. I should mention actually, and that can be very significant. We've certainly seen examples of a 50% reduction in price of a combined visibility and network security solution compared to a network security solution only. So that can be very significant. And then finally, that combination of pushing traffic to multiple tools, load balancing, as well as bypass helps to improve business continuity. And obviously the vendor independence and the removal of vendor lock-in helps to improve operational flexibility for the end user. So that's everything that we were going to cover today. I guess we can move to Q&A now and answer any questions that you have. So feel free to pop those in the chat. Okay, any questions? None so far. We haven't seen any. So I guess we'll give everybody a few seconds to post any questions that you might have.
I mean, also, if you don't have any questions now, you always can reach us via support portal, for example, or email, and then we can also answer at any time.
Okay, we have one from Mustafa Lucas, which says, what about virtual traffic that doesn't go on the wire?
Yeah, a virtual traffic that doesn't go on the wire, typically how we handle is mirror this traffic out via a tunnel, then to the wire. This is typically the option that we choose. So we do not use any virtual tapping because this is, these days getting very complicated with all the Amazon and Google and Microsoft clouds and so on.
Okay, any other questions? Okay, one from Fernando. What can you filter in a GTU user plane connection?
Yeah, I mean, we can filter, of course, outside the tunnel. Okay, so the outer IP addresses, but also we can, with actually all of the, let's say, EX and the EXA units, we can also filter on inside the tunnel without removing the GTP EU header. So we can filter on the user IP address, user destination IP address, so the IP field, but also the inner layer 4 protocol. And if needed, also we can distinguish between 5G and 5GSA user plane. There are specific fields that we can trigger and filter on. But also with the unit that you have just seen, the EXA 48200, for example, as it has a CPU, it also has filtering capability up to layer 7. So we can do with regular expression, we can actually filter on any type of byte combination, let's say, that is inside the packet. So typically whatever is needed, a solution can be found.
Okay, any other questions we can answer for you today? Oh, you're welcome, Fernando. So I guess that's probably everything, I think. So if there are no more questions, I guess we'll wrap up and just say thanks again for your time. Really appreciate you spending time from your busy days today. Yeah, have a great rest of your day. Thanks again. Bye-bye.
Thank you all. Thank you for the attention, and bye-bye.